Sathyabama Institute of Science and Technology.
Hi, energetic learners. Wish you a very blessed day from Dr. A. Viji Amutha Mary, Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. Very glad to meet you again in this video lecture with another interesting topic, Strassen's matrix multiplication. Strassen's matrix multiplication was first invented by Volker Strassen. He first published this algorithm in the year 1969. It uses the divide and conquer algorithm to solve the multiplication problem. Actually, it is a fast multiplication algorithm compared to the traditional multiplication method. So, this algorithm works by dividing the problem into subproblems and then combining the results. So, this multiplication can be performed only on square matrices where n is a power of 2. So, here A and B are the input matrices and C is the output matrix. We divide the matrices into 4 n by 2 by n by 2 matrices as represented below. So, here is the input matrix A and B and the resultant matrix is C. So, first we find the matrix products M1, M2, M3 up to M7. So, the multiplication operations are given here. M1 is obtained by multiplying A00 plus A11 with B00 plus B11. So, first we find the addition of A00 with A11, then find the addition of B00 with B11, then multiply these results. So, we get the value as M1. So, likewise, we are obtaining the values of M1, M2, M3 up to M7 using these computations. So, let us see here. M2 is obtained by adding A10 with A11 and multiplying the result with B00. So, now let us see the matrix. So, the first value is given by A00 and the next is A01. Then in the second row, first column is given by A10 followed by A11. So, likewise, so here the subproblem is divided into n by 2 by n by 2 matrices. So, here we have taken two 2 by 2 matrices. So, when we divide the subproblem into n by 2 by n by 2 matrices, we get actually 1 by 1 matrix. So, each value is taken as a single matrix, that is A00 is a single matrix, A01 is a single matrix. Likewise, we obtain 4 1 by 1 matrices. So, after doing these matrix multiplications, okay, so here actually the matrix multiplications is given in more detail here. The values are substituted here and we get the value, final value. So, M1 equal to A00 plus A11 multiplied by B00 plus B11. So, the values are substituted here, that is 3 plus 6 multiplied by 2 plus 3. So, the value is 9 into 5 which is equal to 45. So, the value for M2 is 20, value for M3 is 12 and the value for M4 is 36 and that of M5 is 24, M6 is equal to 9 and the final value M7 equal to minus 11. So, thus we have obtained the matrix multiplication results from M1 to M7. So, now the next step is to combine the results to form the final matrix C. We are combining the results like this, M1 plus M4 minus M5 plus M7. So, the values are again substituted and we get the final value as 46. Then the next combining result is M3 plus M5 which is equal to 12 plus 24, that is equal to 36. The next result is M2 plus M4 which is equal to 20 plus 36 which is equal to 56. Then the next result is M1 plus M3 minus M2 plus M6. So, the final value is 46. Now, you substitute these values in the C matrix form and this is the output matrix C. So, C matrix is obtained like this, 46, 36, 56, 46. This is the final matrix. So, now we have obtained the final product C. Now, we have come to the very interesting part, that is analysis part. What is the time complexity of this Strassens matrix multiplication? So Strassens matrix multiplication actually does two processes. One is the matrix multiplication operations and the other one is the combining cost. That is, the products are combined and we are obtaining the final result. So these actually there are 7 recursive calls. 7 times we are calling the matrix multiplication operations. So there are 7 recursive calls and each problem is divided into n by 2. Each problem n is divided into n by 2 subproblems. So the time taken for the matrix multiplication operations is given as 7 into t of n by 2. Okay. So 7 is the number of times we are calling the matrix multiplication operations and n by 2 is how we divide a problem n into subproblem n by 2. So the next cost is the combining cost. So after doing the matrix multiplication operations, we combine them to get the final result. So that combining cost takes n square time. So when we add up these costs, the total number of mathematical operations performed is given by t of n equal to 7 into t of n by 2 plus theta of n square. So now look at this recurrence equation, 7 into t of n by 2 plus theta of n square. This is of the form a into t of n by b plus f of n, which we can solve by Master's method. So here f of n is given by n power d. So what are the values a, b and d? So from this recurrence equation we can find the value a, b and d. So a equal to 7 and b is the denominator here, that is 2, and d is the power of n, that is also 2. So let us go to the next slide. So as per Master's theorem, the value of a equal to 7, b equal to 2 and d equal to 2. We compare the values of a and b power d and we find that a is greater than b power d, which comes under case 3. And so the solution for case 3 is theta of n power log a to the base b. Theta of n power log a to the base b. So substitute the values of a and b. So now we get theta of n power log 7 to the base 2. So after computation we get the result as theta of n power 2.8. So thus we prove that the Strassens matrix multiplication reduces the time complexity of traditional multiplication method from theta of n cubed to theta of n power 2.8. So this Strassens multiplication finds its various applications including computer graphics, machine learning and data science, solving systems of linear equations, etc. So thank you learners for listening this video very patiently. We'll meet you again in the next video lecture. Thank you all.